Okay, let's dive into this. The original Death Star, it's supposed to be 140 kilometers across. That's just huge.
Absolutely staggering.
Yeah, and to get a sense of the scale, think about a modern warship, say the HMS Illustrious. That's got about, what, 22,000 tons of steel?
Right. Around.
That figure. Now, if you just kind of scale that density up to a Death Star,
Hmm.
you're suddenly looking at 1.08 times 10 to the 15 tons.
Which is 1 quadrillion, 80 trillion tons. Yeah.
It makes the warship number seem tiny, almost irrelevant.
It really does. The comparison is almost impossible to wrap your head around.
So today we're digging into the, let's say, real-world feasibility of actually building this thing. We're looking at a great article from Incentives, and importantly, the discussion it kicked off in the comments section.
Which was incredibly lively. Lots of interesting ideas there.
Exactly. So our mission here is to pull out the most surprising bits, the real head-scratchers, about what it would actually take, whether you're deep into engineering or just, curious.
Prepare for some aha moments, I think. What really jumps out right away, though, is the raw material question. Iron, mostly.
Right. Steel.
The article makes this incredible point. Earth's core. It has enough iron for, 2 million Death Stars.
2 million, seriously.
Yeah. Now, obviously, the crust doesn't have nearly that much accessible iron, but the core itself is this vast reservoir.
Okay, but, getting to the Earth's core, that's not exactly practical, is it?
Well, no, that's the rub. The practicalities are, let's just say, significant. We're nowhere near that kind of technology.
And the article drives that home, too, right?
Yeah.
And talks about production time. Even if we could get the iron, at today's steel production rates, how long would it take?
Get this. Over 833,000 years.
833,000 years.
Just to produce the raw steel, forget construction, just making the metal.
And compare that to the HMS Illustrious again.
Yeah.
The steel for that takes, what, less than an hour to produce?
Yeah, it's an incredible contrast. It really puts the bottleneck into perspective.
Wow. Okay. But the commenters, they didn't just stop at steel, did they? They got creative.
Oh, yeah. People started thinking, okay, maybe not steel. What about synthetic carbon fiber? Strong, light, made kind of like plastics.
Interesting.
Or advanced polymers, composites. Some even brought up the fictional stuff, like permacrete and durasteel from Star Wars itself.
Okay.
But it's fascinating how this, impossible sci-fi problem gets people thinking about real material science.
It really does. And the ideas went beyond just what to make it out of. Some folks were like, why mine at all?
Right. Why not just grab something that's already out there?
Yeah, like hollowing out the moon, which sounds completely nuts.
Talk about extreme home renovation.
Or maybe grabbing a big iron-rich asteroid, like Vesta, I think someone mentioned.
Yep. Hijack an asteroid. Bring the mountain to Muhammad, sort of.
But then you have to think about the consequences, right? Messing with the moon, what does that do to Earth?
Exactly. You start thinking about tides, navigation, maybe even its orbit changing slightly. These aren't small things.
It really highlights how interconnected everything is, gravitationally speaking. Even the moon just sitting there is important.
Definitely. Tampering with something that massive could have some really serious, unintended knock-on effects. It's a delicate balance.
Okay, so materials, massive challenge. Maybe you need to think outside the box or outside the planet.
What about the cost? The money?
Yes. The price tag.
The original article used the warship scaling, I think.
It did initially, but then a commenter made a really good point. Maybe a Nimitz-class supercarrier is a better comparison point for complexity.
Okay, so more than just metal. It's got systems, tech.
Exactly. And using that as a model, the cost estimate just exploded. We're talking $4.05 times 10 to the power of 19.
$4.5 quintillion, is that right?
Something like that.
Yeah.
It's a number that basically loses all meaning. It's just huge.
And it makes sense, right? A carrier isn't just a big ship. It's weapons, electronics, power, life support, all incredibly complex.
Precisely. Scaling up just the steel cost completely misses all that intricate stuff, all the R&D, the systems integration. Plus, as someone else pointed out, using today's money, today's GDP, for a project supposedly set a long time ago, it's a bit shaky.
Very shaky, especially when you remember that 800,000 plus year timeline for just the steel?
Oh, God, yeah. Inflation over almost 1 million years.
Forget about it. The cost becomes, well, insert your own adjective. Astronomical doesn't even cover it. Any estimate today is just a wild guess.
The whole economic system could be unrecognizable by then.
Absolutely. Currency, technology, value itself. It's impossible to project that far out.
And it's not just the materials and the build time adding to the cost. The commenters really dug into the other stuff, too.
They did. Like power. How do you power this thing? Fusion reactors were suggested. You need something immense.
For the weapon, obviously, but also just keeping the lights on.
And the weapon itself. Lasers, plasma, something else entirely.
Then all the internal stuff. Life support for potentially millions, maybe billions of people. Artificial gravity.
Getting it all into space. Launch costs are astronomical now for small satellites. Imagine lifting quadrillions of tons.
And who built it? Labor costs. One comment joked about needing trillions of crew. Or maybe droids. An army of droids.
Each one of those is a colossal project in itself, with costs we can barely estimate today. It's not just a sphere, it's a mobile, weaponized world.
And then there are the more boring bits people brought up.
Huh, like what?
Like zoning permits, galactic zoning permits, dealing with bureaucracy, kickbacks, inspectors.
Oh, brilliant. Even the Empire has paperwork, presumably.
And waste disposal. Where does all the garbage go on a planet-sized station?
It's funny, but it's true. Those mundane things are real considerations for any massive project. It grounds the fantasy a bit.
So then you get into the wider economic effects. Could it be a massive stimulus package? A Death Star industry?
Maybe. Generating spin-offs, new tech.
Or would the whole thing be obsolete before it's even finished? Someone joked about death black holes being cheaper and faster by the time it's done.
That's a really serious point, actually. Opportunity cost, all those resources tied up for potentially hundreds of thousands of years.
Yeah, while technology marches on, you could invest in something that becomes a museum piece before it's even operational.
That risk of obsolescence over such a vast timescale is enormous.
Okay, let's pivot a bit. Feasibility, tech. The article mentioned something surprising about gravity, didn't it?
It did. Based on the size and estimated mass, the surface gravity would actually be pretty weak, much less than Earth's moon even.
Really? So all that mass, but spread out so much.
Exactly. This got the commenters talking about mass versus weight. Can I clarify that quickly?
Yeah.
Okay, so mass is just how much stuff is in an object. It's constant. Weight is the force of gravity pulling on that mass.
Gotcha.
So the Death Star has incredible mass, but because it's so spread out, it's mostly empty space inside that huge volume. The gravitational pull at any point on the surface wouldn't be that strong. You wouldn't feel very heavy.
Right, okay, so you need artificial gravity, like in Star Trek.
One suggestion, yeah. Or maybe rotational gravity. Spin the station. Use centripetal force.
Like in 2001, A Space Odyssey.
Exactly like that. Ingenious, but it adds complexity. Structural stress, maybe weak points if it stops spinning.
And these are real concepts engineers think about for space stations,
Oh,
right?
absolutely. Generating artificial gravity for long space missions is a big area of research.
And then there's all the other tech, the really sci-fi stuff. Hyperdrive, faster than light travel.
Planet-killing lasers, deflector shields, tractor beams.
Things we just can't do. Not even close.
And as one commenter pointed out, how do you even begin to cost that? There's no frame of reference. It's pure invention.
Yeah, estimating the cost of steel is one thing. Estimating the cost of a working hyperdrive is another level.
Completely speculative. We touched on power, probably fusion reactors. That seems the most plausible sci-fi energy source.
And then, of course, the crucial question. The operating system.
Yes, the comments had fun with that. Windows, Mac, Linux.
Someone dreaded the idea of a galactic-scale blue screen of death.
Or maybe it runs on some ancient but reliable mainframe.
It's funny, but it highlights complexity. The software needed to run something like that would be insane, unbelievably complex, and needing to be absolutely foolproof.
You'd need something entirely new, presumably, and incredibly robust.
It also makes you think about how the Empire supposedly built these things relatively quickly.
Right. The implication is maybe a vast slave labor, a totally centralized command economy. None of the free market issues we face.
Things like unions, environmental reviews, public consultation. Probably not big concerns for Emperor Palpatine.
It does raise that awkward question. Could a massive authoritarian regime actually be better at mega projects? Setting aside the huge ethical cost, obviously.
It's an interesting thought experiment. The trade-offs between efficiency and freedom, maybe?
Centralized power versus the sometimes messy, slower process of democratic, market-based approaches.
Now, we have to mention the humor in the comments. That was definitely a highlight.
Oh, yeah. People had some great suggestions.
Like, forget the Death Star, just build a Borg cube. Probably cheaper, maybe quicker.
Less aesthetically pleasing, perhaps, but efficient.
Or maybe start smaller. An econo-sized Death Star for beginners.
A death moonlet.
Huh. And the really out there ones. using recycled beer cans for hull plating.
Powering it with giant solar panels wrapped around it.
The nightmare of wiring the thing. Imagine the electricians union on that job.
And the cost of paint? Gallons upon gallons? Or the floor coverings?
It sounds ridiculous, but it helps grasp the scale, doesn't it? Applying everyday problems makes the absurdity clearer.
It really does. It brings this fantastical object down to Earth in a funny way.
And finally, people commented on the whole exercise itself. What's the point of calculating this for a fake spaceship?
Yeah, the meta-commentary.
But others defended it, saying it's fun, it's a great thought experiment, and maybe it sparks real ideas, even indirectly.
And I think that's a fair point. Analyzing the impossible forces you to confront real limits, think creatively about solutions. It's valuable speculative engineering. It pushes boundaries, even if only in theory.
So, okay, let's try and wrap this deep dive up. Building a real Death Star verdict.
Wildly impractical, astronomically expensive, technologically impossible with current or foreseeable science.
Pretty much sums it up. The sheer scale, the materials, the time involved hundreds of thousands of years just for production. It's mind-boggling.
Yeah, those two numbers really stick with you. Enough iron in the Earth's core for millions of them, but over 800,000 years just to make the steel for one. That gap is immense.
And yet, look at the discussion it generated. The comments show this deep human fascination with huge, ambitious, even impossible projects.
Absolutely. The sheer range of ideas, from serious engineering proposals to jokes about paint, it shows that drive to imagine and problem solve on a grand scale.
That collective brainstorming, even for fiction, is pretty cool.
It really is. It shows that innate curiosity, wanting to figure out how and what if, pushing the edges of possibility.
So let's leave our listeners with a final thought. Considering the resources, the time, the sheer willpower you'd need for something like a Death Star. Forget a Death Star itself for a second. What could humanity achieve realistically if we focus that kind of effort over, say, the next few centuries, or even millennia? If we could solve even a tiny fraction of the challenges involved, energy, materials, large-scale construction in space, what other amazing things might suddenly become possible?
That's a great question. It forces you to think about long-term potential, about what happens when sustained focus meets human ingenuity. Maybe the value isn't building the Death Star, but developing the capabilities as if you were going to.
Definitely something to ponder. We really encourage you, if you found this interesting, to check out that original Sendeds article and especially the comment threads. There's way more detail and quirky ideas in there.
For sure, it's a fascinating rabbit hole to go.